Hi everyone. In the given problem statement, we are going to solve binary tree right side view. This type of problems can be solved using the breadth first search approach. So you're going to give a root of a binary tree. Imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. So now let us take this tree. We have the value of 1, then we have another value 2, and then value 5, 3, and 4. And if I'm standing on the right side, then what are the values of the tree that I am able to see? So I'd be able to see 1, 3, and 4. So those would be the output. Now, to solve this, right, we need an BFS approach. So now let us do one thing. Let us create a DQ, and we can add the elements out here. Initially, it is going to be null, or it is going to have the value of root for the initial point. We can also have a result where we are going to store all the elements on the right side, initially empty. Now what we're going to do, we are going to be at the topmost position, and here, right, I'm doing pop left. So whatever the elements that are on the right hand side, right, or the zeroth index element is going to get popped out. So initially the value that is going to get popped out is going to be 1. So 1 got popped out. Let's say, let me type in, let's say just have the values out here. This is the DQ, and the result empty for now. So I popped out this element, and once I popped out, I am going to search what are the values of its left child and its right child. So the values of left child and right child are 2 and 3. So once we got 2 and 3, so we're going to add 2 and 3 to our queue, DQ. And now, because 1 is the last most element in that DQ, right, we are going to add that to 1 to the result. Once that is done, right, now we are going to move to the next pointer. And here, right, we are writing a for loop where we are going to search the which is 2 and 3 that are present out there. So for 2, right, what are the left child? It does not have any left child, only right child is there. So right child is going to get added. So we are adding the right child. And now 3. 3 is the last element in this entire level, right? So we're going to add 3 to our result. And what are the values of these left and right? So 4 is the right child. It does not have a left child. So 4 got added out here. Now we are going to compare. So we are going to loop through or just traverse it up. And here, right, 4 and 5 are there. So 5 got popped out. And the value of 5, right, it does not have any left child or right child, so nothing is going to get added to our DQ. Similarly, 4 is going to get popped out, and 4 is the last element, so 4 is going to get added to the result. But 4 does not have any left child or right child, so 4 nothing is going to get added to the DQ, and our while loop is going to end because we are writing an while loop from where, in case the stack or DQ is empty, it is going to run while it's not empty till the point it's going to run. So that's the idea. Now if I jump to the Python solution, I think the understanding right how it's going to work, it is going to be clearer. So for using breadth first search, we are going to require initially a while loop and then a for loop to traverse these elements on that level. So that's the idea. Now let us jump to the Python solution. So the first thing we are going to do, we are going to add a DQ. So for adding a DQ, we need an import statement. So import collections. You can do it using a stack also, so it does not matter that much. So the first thing we're going to do is going to check, as always in tree, if the root is empty. So if not root, then we are just going to return an empty list. So that's the idea. Now we are going to create, let's say, just give it a name of queue, which is going to be dq, and here we are going to initialize with the value of root. Once that is done, so while our queue is there, and also you have to create another variable called result, which is going to be empty list for now, or empty array. So while there are some values present in our dq, right, it is going to keep on looping through it. Now we are going to have one more variable called previous, which is going to be none, so that we are going to keep a track what would be the last element in a row or in that level to get traversed. So we are going to keep a track of it. Now we are going to write a for loop. So for in underscore in range of 0 to length, current length of our queue. Once that is done, we are going to do cur equal to queue dot pop left. So the reason for using dq, right, we can pop elements from both left and right side. In case if you're using some stack or a normal queue, right, you have to do, right, take the first element of that queue or of that list and store it and then delete it. So it's going to be too many operations. It's better to use this, but it's not very important. Means if you know normal data structure, you can use that. So previous is going to be our current value, and now I'm going to check whether our whatever node that we are working on, right, does it have a left child. If it does have a left child, then q dot append cur dot left. In case also if it has a right child, then it would be q dot append cur dot right, and at last it would be res dot append prev dot val. So that's the idea. And at last I'm going to return, yeah, I made one mistake. It would be inside, yeah, and I have to return it. So it would be return our result that got added. So in this way, right, we are storing all the elements that are present on the right side of the tree. Let me run it. Yeah, I made one mistake. I need to give an S in collections. Let me run it back again. As you could see, the public test case is passed. Let me submit the code. And as you could see, the code got submitted, and it would be a linear time solution because we are traversing all the nodes one time. So the time complexity would be big of n, and it is beating 100% the submission. So our code is pretty efficient. That's all for this video. See you in the next one.